All right, welcome. Today we are cranking the heat way up and diving headfirst into the absolutely incredible world of cast iron. We're going to explore the powerful, white-hot technologies that turn mountains of cold, solid scrap metal into the liquid gold that really builds our modern world.
You know, when you think of heavy industry, what you're really thinking of is cast iron. I mean, from the massive engines inside these giant trucks to the pipes running under our cities, this stuff is the literal backbone of our infrastructure. Its strength and durability are just legendary, making it the go-to material for the biggest, toughest jobs out there.
And that's the real question, isn't it? How do you get from a pile of recycled metal to a precision-engineered part that has to perform flawlessly? Well, that whole journey starts with one single critical step, melting. And how you melt it, that changes everything.
See, choosing a furnace isn't just about making metal hot. No, it's a huge strategic decision. It's a choice that impacts everything: the cost, the quality, the environmental footprint. It is the very first thing you do that determines the final structure and properties of that finished part.
So, you know what we're going to do? We're going to frame this as a championship match. We're putting the different melting technologies head-to-head to see who really comes out on top in the high-stakes game of the modern foundry.
So let's meet our contenders. Now, while there are a few ways to melt iron, the industry is really, truly dominated by two heavyweights, with a couple of other powerful specialists hanging around the edges.
And it really all boils down to these two. In this corner, you've got the Cupola furnace. Think of it as the seasoned, coke-fueled champion. It's old school, and it's built for massive volume. And in the other corner, you have the Induction furnace, the clean, electric-powered challenger that's known for its incredible precision.
And the numbers really tell the story of just how dominant these two are. Cupola's, this ancient technology, still melts a staggering 60% of all cast iron tonnage today. It's amazing. Induction furnaces handle about 36%, and then everything else, like electric arc furnaces, they're crammed into that last 4%. So yeah, this is truly a battle of titans.
Okay, time for the main event. We're going to compare these two technologies across 3 critical rounds to really see where their strengths and weaknesses are.
First up, let's talk about sheer production power. I mean, how much iron can these things actually melt, and how fast can they get it done?
Okay, so the Cupola is an absolute beast. It's designed to run continuously, just churning out this nonstop river of molten iron. It's perfect for those huge foundries that make the same thing all day, every day. The induction furnace, on the other hand, it works in separate batches, and this makes it incredibly agile. You can melt one type of iron, pour it out, and then immediately start a brand new batch with a completely different chemical makeup.
All right, let's talk money, because melting this much metal is not cheap. So how do the economics of our two contenders actually stack up?
You know, what's so interesting here are the trade-offs. Building a Cupola plant is a massive investment. We're talking roughly double the cost of an induction setup. But once it's up and running, it can use cheaper, lower-quality scrap metal. Induction furnaces are cheaper to build. They need fewer people to run them, but they need cleaner, more expensive scrap. And of course, they're completely tied to the fluctuating price of electricity.
And in today's world, this might just be the most important round of all. What's the environmental cost of all this incredible heat and power?
This chart just illustrates the key differences perfectly. Because the Cupola burns coke, it has a high global warming potential from all the CO2 it pumps out. Now you can also see that third type here, the electric arc furnace, which produces a lot of sulfur dioxide and nitrogen dioxide. That's the stuff that causes acid rain. Then you have the induction furnace. Running on electricity, it generally has the lowest direct impact, though of course that always depends on how that electricity was generated in the first place.
So far, we've talked about speed and cost and the environment. But what about the quality? Getting the metallurgy just right is the difference between a high-performance part and a pile of expensive scrap. This is where precision becomes everything.
I mean, just look at this list of potential problems. Shrinkage cavities, rough surfaces, warped castings, cracks. Getting the chemistry or the temperature just a little bit wrong can lead to a whole catalog of defects that make a part totally useless. The stakes for getting the melt quality right are, well, they're incredibly high. So the key word here is control. And this quote from the source material just says it all. In a cupola, the metal is physically touching burning coke, which introduces all sorts of chemical variables you have to deal with. But in an induction furnace, the heat is generated inside the metal itself. This gives metallurgists so much more fine-grained control over the final chemistry.
And this level of control is exactly why induction melting is the absolute go-to for advanced materials like ductile iron and compacted graphite iron, or CGI. I mean, these are the high-performance irons used in the most demanding jobs. Think lighter, stronger engine blocks, or critical suspension parts. They require incredibly precise recipes and super low levels of impurities, which is just so much easier to achieve in the clean environment of an induction furnace.
And modern foundries have this down to a science. They use a technique called thermal analysis. They'll pour a tiny sample of the molten iron, and as it cools, a computer analyzes its temperature curve. Now, this curve acts like a fingerprint, revealing the iron's exact chemical makeup and structure in a matter of minutes. This gives the operators just enough time to make those final little alloy adjustments right before they pour. It's brilliant.
So, after 3 rounds comparing power, price, and precision, who's the winner? It's time for the judge's decision.
And the verdict is, it's a split decision. For sheer raw tonnage of standard gray iron, the Cupola's ability to run non-stop on cheap scrap means it is still the undisputed king. But for flexibility, for precision, and for producing those high-quality specialized alloys like ductile iron, induction is the clear, hands-down winner. But the story does not end there. The future isn't about one replacing the other, it's about them working together. The smartest foundries are using a hybrid approach called duplexing. They do the heavy lifting, that initial high-volume melt, in a cost-effective cupola. Then they transfer that liquid metal to an induction furnace for the final tweaks and precision chemical control. They're literally combining the strengths of both to create a system that's better than either one could be alone.
And that really brings us to our final thought. As these amazing technologies continue to merge, and as new tools like AI and advanced sensors give us a level of control we've never had before, those old lines between brute force and fine precision, they're starting to get pretty blurry. It just makes you wonder, what incredible new materials and capabilities will the foundry of the future unlock?